Now I want to introduce 3 ideas from section 5.3 of your reading using this homework from section 5.2. I want to illustrate 3 ideas. The first idea is that of equilibrium pair, or otherwise known as a Nash equilibrium pair after John Nash, the mathematician who first described this particular notion. Look at the solution to this game, R2, C2, that we reach via dominance reasoning. Notice that if the pair hit upon this particular pair, neither of them has any reason to unilaterally change his or her selection. If they're here, rho has no reason to change from R2 to R1 because that would be giving up and losing, only earning 1 plus 1 instead of 2. But if they're on this point as well, column has no reason to unilaterally change his or her choice because that would be moving from -2 to -4. So this point is in Nash equilibrium. Neither person, if they hit that point, has any rationale for unilaterally changing his or her choice of strategies. And notice that that is not true for any other point on this particular matrix. If they got on this point, right? Well, if they got on this point, rho would have a perfectly good reason for changing from R2 to R1 to gain 10 instead of gaining 4. And column would have perfectly good reason to change from C1 to C2 and go from -4 to -2. No other point of all the other 5 points has the property that this point has, in the sense that if they're on this point, they will never leave, neither of them would ever have any reason to unilaterally leave this point for any other choice. This point alone in this particular table is in Nash equilibrium. Notice also that this particular point passes what Resnick calls on page 130 the Minimax Equilibrium test, another test devised by John Nash. The test is this. Is there a point on this particular table, this game table, is there a point at which it is the minimum value for rho in that particular row, and also the maximum value for column in that column? Okay, and you can see that this particular point is the minimum value for rho in R2, and it's also the maximum value for column in C2. And no other point has that particular pair of properties. This point is not the minimum value for rho, or consider this one. This point is the minimum value for rho in C2, but it's not the maximum value for column. So none of these other points has this passes this Minimax equilibrium test. Only this particular point does. So this particular point is the only point on this table that is in Nash equilibrium. Notice that this particular point, by being the minimum value in this row, maximizes the best payoff column can expect. But as being the maximum value in this column, it guarantees the biggest outcome for rho. One more point and then we'll wrap up. Security level pairs. Notice that this particular point right here is rho's security level. Look at this particular row, R2, and notice that the worst rho can do by choosing R2 is an outcome of +2. Whereas the worst rho could do by choosing R1, rho could get as low as an outcome of +1. Notice also that this particular point passes column security test as well, security level as well. By choosing C2, the worst column is going to do is -2. Whereas if column chooses C1, could do as bad as -10, and if it chooses C3, could do as bad as -4. So R2 is the security choice for rho, C2 is the security choice for column, and once again, that indicates the point in this particular table by all 3 of these measures, which is in Nash equilibrium.